Question 3, I'm actually enjoying going through these. I don't know, just kind of just step through them and see what are they trying to do. And for me, it's really about reinforcing all those same things. Given an input, what's the output? Given the output, what's an input? We know how to find x and y intercepts. We know how to find turning points. And they're not really throwing anything else at us here, except maybe just this idea of these reflections now. Okay, so f of x is given to us here, 2x minus 1 squared minus 18. Okay, this is the parabola, so let's draw directly of this parabola like this. And the straight line is given to us as mx plus k. Don't really have too much information about the straight line at all. We do know that the gradient is going to be negative, but it doesn't help us all that much just yet. Okay, so let's go through and see. Let's just look at our graph first. A. What is special about point A? That's also special about point B. X-intercept. So this is the x-intercept, so we know our y value is 0. It's also the x-intercept of the straight line. So that might be useful, might not. But I'm going to maybe just underline it in purple because it applies to that as well. Okay, H, GH, we don't know what's happening there yet. C, okay, C is the y-intercept of the parabola, so we know its x value already. And we could quite quickly find out what its y value is, but I'm sure it's going to come up in one of the questions. And question at least, point D, well, that's our turning point of the parabola. Ooh, this is in turning point form. You know what, I'm going to put it in straight away. X minus p squared plus q, so p is 1. Remember that whole idea of the p, and it's still kind of getting into this of, well, it's minus 1, so it's moved right, that's fine, but our p value is this, it's minus p, so p is 1. P isn't negative 1, p is the x value of our turning point, and q is our y value of our turning point. Okay, then we've got point E. Well, that looks like it's going to be special because it's where the two graphs are equal to each other. So that's E, and point A is also where they're equal to each other. So point A is performing a lot of functions here. Okay, cool. And these lines are probably going to tell us are parallel. In other words, they look like they're straight up and down. They are. This one looks like it's straight across. It is. I think that's enough familiarizing ourselves with the diagram, but it'll give us a good sense. So probably go off and try and do these questions if you haven't, and see if that bit of information, those bits of information help. Okay, but let's run it. Coordinates of A, B, C, D. D tells us is the turning point. It's not just a little bit off. And E, if CE is parallel to AB. If CE is parallel to AB. Just means that they're parallel, they've got the same Y value. So at this point here, in my head I'm kind of thinking, well, if I can work out what this Y value is, I can work out this Y value because it will be the same. If I can work out that Y, I can work out the X. Okay, so let's go through it step by step. A and B we said were the x-intercepts. So the output's 0, so we can work out the input. So let's just substitute it into our equation. And yeah, we can substitute it in, it's going to be the same. I was going to say we need to multiply this in, but we're going to have to and square it right now. So 0 equals 2x minus 1 squared minus 18. Got an equation, we need to solve it. We're going to need to square it and then multiply. So 0 equals 2x minus 1 squared minus 18. 0 equals 2x squared minus 2x plus 1 minus 18. 0 equals 2. Here's a little trick actually, because it's going to be a useful trick. At this stage we can divide our entire equation by 2. We could have done it right at the top. So let's divide this whole thing. 0 equals x squared minus 2x plus 1 minus 9. Because we can divide by 2, instead of multiplying this 2 into the bracket and then doing it in the next step, let's save ourselves some time. So 0 equals x squared minus 2x plus 1 minus 9 minus 8. Does it look like it's going to factorize nicely? If so, let's factorize. If factorizing doesn't come to you straight away, quadratic formula for the win. But this one I think is going to be 4 and 2 minus 4 plus 2. So from that one, x equals 4. From this one, x equals minus 2. Okay, what we're working on again. If you've been watching any of my videos, you'll know that I would like to sum these up as what we were trying to find again. Well, when the output was 0, we worked out the input, and on top of that, I like to label them. So whenever we come back to them, we can go, what was that point again? Okay, so A was the negative 1, and B was this one. So minus 2 and 4, minus 2, and let's put in the diagram. Okay, so we got A, we got B, C. We looked at the diagram at the beginning, we said, well, C is just the y-intercept, x is 0, what's y? Now, let's substitute x equals 0. You'll see why I was wondering about another way, and I'll tell you what the other way that I was thinking of is, but let's just go with simple. F of 0, so f of 0 equals 2, 0 minus 1 squared minus 18 equals, that's 1, that's 2, 2 minus 18 minus 16. What we're working out? We're working out this point here, which was point C, so 0 minus 16. Okay, what I was umming and ahhing about is we could have rearranged our equation so we've got it in ax squared plus bx plus c form. It's probably going to be useful to have at some stage, so we could have then substituted the 0 in and got our c value quite quickly. But we're going to do that right now anyway, because d is our turning point. We actually don't need it just yet. D is our turning point. We already just found that out. There it was, 1 minus 18. So we've got D is 1 minus 18. And what else do we need? And E, if CE is parallel to AB. So we said that this had the same Y value. So therefore, what is its X value? Substitute. Minus 16 equals 2. This is like an unnecessary amount of work, doesn't it? Okay, two options here. 1, go through all of this work. X minus 1 squared minus 18. Divide everything by 2 straight up. X minus 1 squared minus 9 minus 8 equals x squared minus 2x plus 2 minus 9. And 0 equals x. Okay, this is going to take us a while, but it's the one option. I'm going to show you the other option because it's really fairly easy to do. But let's run through this. Minus 2x minus 7 plus 8 is plus 1. 0 equals x minus 1. What am I missing here? Minus 16. We should have had an x and an x. Okay, so my thing says here that x equals 1. Did I substitute in minus 18? It's like I substituted in the turning point. Okay, let's spot my error. Minus 16 equals 2x minus 1 squared minus 18. Divide everything by 2. And can you spot it? Minus 2x plus 1. Here we go. Minus 8. See, I tried to skip a step and that's where it got me. Minus 1 squared is plus 1. So let's scrap everything from here. I was getting too distracted by the other exciting way of finding the answer. Okay, so we've got, go away, go away, go away. 0 equals, so minus 8, they cancel. X minus 2, x equals 0. That's what we're expecting one of our answers to be, because that's that one. Or x equals 2. So what we did there was just said, we know the output's negative 16, let's work out the input. So we substituted in, we got two values. one corresponded to C, the other one to E. So that one we're going to disregard. X equals 2. So therefore point E is 2 minus 16. But you're going to see, the reason that I'm saying this is feels like a lot of unnecessary extra work. Look at these points here. Here's our turning point. Its x value is, if we just looked at our number line, its x value is 1. Then we've gone left to this point where the x value is 0, and we know that the y value is negative 16. Now this other part's just perfectly symmetrical. So we must also have gone across by 1, getting us to 2, which would get it to the same y value, because it's perfectly symmetrical. So just from getting point C, if that was at 0, which it is, this one's at 1, this one must be at 2. And we could have gone straight there rather than all of that algebra. Algebra is not wrong, it's just a more long-winded way of getting there. Okay, so we got these things, that's it. Okay, find the values of m and k. In other words, determine the equation of the straight line. How do you find an equation of a straight line that goes through 2 points? We're not given the y. Well, we've just got gradient equals what? Rise over run. How far? So we're going to go from this point minus 2, 0 to this point 2 minus 16. I'm going to start with the run. So if we're running, we're going from minus 2 to 2. So we're going across by 4. And how far are we rising? We're going from 0 down to minus 16. So we're rising by negative 16. So we've got negative 16. Cool. Negative 16 over 4. Negative 4. So y equals minus 4x plus, I said plus k. How do we work out k? Well, we seem to do this quite often when we're trying to find the equations of our functions. We just sub in one of the points, and you can choose either of these 2 points. I'm going to choose this point here. Just feels a bit easier. There's a 0. Maybe that'll make life easy. So we've got sub in the point, what was it? Minus 2, 0, minus 2, 0. So we've got 0 equals minus 4, x values negative 2, plus k. So this is 8. So negative 8 equals k. Does that sort of feel right? Is that about negative 8? Diagram's not to scale, but it's definitely between 0 and negative 16. So there's our final equation. G of x equals minus 4x minus 8. Okay. 2 more questions. And the last one, you're not going to get too many of these questions this year. We're going to cover it next year in calculus, actually. Find the range of y equals minus f of x. Really being sneaky here. So range deals with what? X or y values. Deals with our y values. So if we wanted the range of this function, f of x, it would have just been everything greater than negative 18. But it says the range of y equals minus f of x. So in other words, we're going to have to take this function and we're going to have to reflect it about the x-axis first. So I'm going to take this function and I'm going to draw it in, because then we can see what's happening. It's going to look like this, and then have the same x-intercepts, and there it is. And so our range is now everything below that point. Well, everything's just been reflected, so that point's still at 1, but the y value, 18. So therefore our range, y is an element of smallest value, negative infinity. Biggest value we get up to is 18, and we're including it. If you do it in the other form and you say y is less than or equal to 18, just remember to say that y is a real number as well. Okay, so our last question. The maximum length of GH, where's G anywhere? Here, GH, if H is a variable point in the parabola between A and B, GH being parallel to the y-axis. Okay, I have it on good authority from Dr. Sampson that we don't have to do that type of question. It doesn't just relate to the turning point like our previous in question 2. So we're not going to do it. Do not worry about it. There we go.